Assalamu alaikum everyone. This is Probability and Statistic for Engineers course in the Department of Civil Engineering, International Islamic University. Today we are going to discuss about standard normal distribution. Previously in last week lecture we have discussed normal distribution and histograms. In this lecture we will study about normal distribution or standardization of normal distribution. Okay, so what is standard normal distribution? Standard normal distribution is a normal distribution of continuous random variable having mean 0 and standard deviation 1. Now in case of normal distribution, I have already mentioned that we have mean is equal to mu and standard deviation sigma, and then we have probability density function equation. We can input mean, we can input standard deviation in that equation to determine the probability density values. But in case of standard normal distribution, we make the things easy and we transform that normal distribution into standard normal distribution. And what we do, we keep mean is equal to 0 and standard deviation equal to 1. So if we standardize that, we will be having 0 at the line of symmetry, and we have 50% area on the left side and 50% area on the right side of that standard normal distribution. Now what we do, instead of x as a random variable, we change it to z. So as we have standardized mean and standardized standard deviation, similarly we change or we transform our random variable x to z and we call it z value or z score. How to do that, I will discuss that in next slide. Okay, same like normal distribution, standard normal distribution having a mean 0 and standard deviation equal to 1 will be having area equal to 1. Area under the curve will be equal to 1. Now how to transform z score to x to z score? We have an equation that is mean value mu and sigma. We can take the random variable value x minus mean and its standard deviation. If we have x is equal to 15 and we have mu equal to 7.5 and standard deviation equal to 2, so what we do, we just plug in our data in this equation and determine the z score, and by using z score we determine the probability values. Sorry, if each data value of a normally distributed random variable x is transformed into z score, then the standard distribution will look like this. So a normal distribution is transformed to a standard normal distribution. Normal distribution has value mean is equal to mu and standard deviation equal to sigma. Now it is transformed and that is equal to 0 and standard deviation is transformed and equal to 1. Now use the standard normal. Okay, let me rub all this. Use the standard normal table to find the cumulative area under the standard normal curve. So we will use a table that will help us to determine the area, cumulative area, and that cumulative area is basically probability values. So properties of standard normal distribution. The normal distribution is the cumulative area is close to 0 for z score is equal to minus 3.49. okay, as I have mentioned that we have a mean 0, we have a mean 0 at a line of symmetry, and we will be having same area toward right and same area toward left. So if we go toward, and that is z score, so z score here is 1, here z score value is 2, here z score value is 3, same here z score value is minus 1, here z score value is minus 2, and z score here is minus 3. Now the z score value at minus 3.49, this point, this region is showing area equal to 0, so here the probability value is equal to 0. okay, same here at this region, that is z is equal to 3.49. at this region we will be having probability equal to 1. Now if we take this point as a reference point, the left side as a reference point, so we sum all the probabilities values, and if we to go toward 3.49, so we will be having a probability value as 1. okay, where's all. The cumulative area increase as z score increases. If we go from left to right, side, so the probability, the cumulative area increases, and same the probability value also increases. The cumulative area for z is equal to 0 is 0.5. so this whole area is equal to 0.5 at z is equal to 0. okay, so the cumulative area is close to 1 for z score, close to z is equal to 3.49, as I have already mentioned that. Now this is a standard normal table. Let us find the cumulative area that correspond to a z score of 1.15. We have already used this equation, x minus mu divided by sigma. We transform x to z by using a value of x in this equation, mu in this equation, and standard deviation in this equation. Now I have obtained, let's say I have obtained z score value as 1.15. so how I'm going to read this table? In this table, at the top left corner I have z, and the value of z's are increasing downward in the leftmost column. So for example 0.0, so this column is showing me the single digit after decimal, same 0.1, 0.2, and the second digit after decimal we can read it from this first row. So if I have a value 1.15, so it will be 1.1 starting from here, 1.1, and I will go somewhere here this value, because I have taken 1.1 from the leftmost column and 0.05 from the first row. That gave me the probability value of 0.8749. So that is the way you read the standard normal table. How about cumulative area that correspond to a z score of minus 0.24. So in that table that I'm also going to share with you, in that table the z-score in the leftmost column 0.2, you choose 0.2 in here, and that is 0.2 here. So 0.2, and then the second digit is 4, so it will be somewhere here, that is 4 and that is 2. So we intersected here, sorry, where is okay, let me erase all. So 0.24, we start here, sorry, we start here to 0.4, 4, it's here and here, so we intersect at this point. So 0.4052 is the value of probability. Okay, so that is showing me the probability value. So that is very simple, just to transform random variable x into a z-score and then obtain the probability value from the standard normal table. Sketch the standard normal curve and shade the appropriate area under the curve. Find the area by following the direction for each case. To find the area to the left of z, find the area that corresponds to z in the standard normal table. Now if you are going to have a value 1.23, that is to the right of mean value, mean z is equal to 0, and the total probability value in that table from starting from here to here, that will give you the respective probability for z is equal to 1.24. So from the table, that is 0.8907. To find the area to the right of z, use the standard normal table to find the area that corresponds to that, then subtract from the 1. So you know that this whole has area equal to 1, and what we are going to determine, we just want to check the area that is greater than 1.23. We want to determine this, but table will give you value from left to from so the table will give you the value from left to right side. So in order to obtain the value of 1.23, you need to check the table, and table will give you value for 1.23. If you determine the value of probability from the table, that is actually the area for z is equal to 1.23 is 0.8907. So area more than 1.23 is 1 minus 0.8907. And that will give you the value. Okay, now to find the area between two z-score, find the area corresponding to each z-score in the normal table, then subtract the smaller area from the larger area. Okay, so what you do, you calculate the respective area for this and respective area for 1.23. What you do, check the value of z-score value of minus 0.75 in table and determine the respective probability, and also check the value of 1.23 in the standard normal table and find the area. Now the area of 1.23 will of course be greater than the area of minus 0.75. So subtract the area of minus 0.75 from the area of 1.23 to determine the area in between these two z-score. Now you can see here that the area to the left of z, that is 1.23, is 0.8907, and the area to the left of z is equal to minus 0.75 is 0.226. So the area in between them will be 0.8907 minus 0.2206. It is corresponding to 1.23 and this is corresponding to 0.75. Then the area, this is the area which is actually showing this region. Find the area under the standard normal curve to the left of z is equal to minus 0.9. So same, this will be the area under z score, which is 0.1611. From the standard table, the area is equal to 0.1611. Find the area under the standard normal curve to the right of z is equal to 1.06. So you have 1.06 here, and you will get the value of 0.8554, which is actually this area, and you are going to determine the area of this region. So what you do is you just subtract 1 minus 0.8554. So same you can do from area between minus 1.5 and z is equal to 1.25. You can determine area for 1.25, and then you can determine area for minus 1.5, and then you subtract that to get the area in between. Okay, thank you for today's lecture.